there definitely is a high demand to have a sort of a strategic, coordinated approach that leverages international engagement in an expedited manner in order to solve this challenge. We need to think about the dietary composition and how that influences methane emissions. In our world, we like to generalize percent efficacy for various feed additives, but in reality, methane production per animal is quite dynamic. And so in this particular case, they were looking at various forage concentrate ratios, which I like to look more at sort of the fiber content of the diet. That would be NDF content of the diet or starch content of the diet. Here, they were able to show as you increase NDF intake, you're going to dramatically increase methane production, which significantly increased. Methane yield per unit of dry matter intake also increases, and methane intensity per unit of milk or energy-corrected milk increases as there's more fiber in the diet. So NDF, starch, sugars, the fat content of the diet, these are all variables of the diet that can significantly impact methane production. Therefore, it's reasonable to expect that these components of the diet will also impact efficacy of these feed additives. In addition, host and microbial genetics, environment, health status, and management are some other factors that can influence efficacy. Seaweed is a potent methane inhibitor. I'm sure everybody knows this already, but there is some improvements in feed efficiency, but this is at the expense of voluntary feed intake. And so what happens in scenarios like a fresh cow that typically experiences a drop in feed intake, is that potentially compromising the animal in any way? We need to be concerned about various residues in milk like bromoform and bromide that can accumulate, as well as iodine, which we see in panel C. We also need to be wary of any kind of unintended consequences on animal health. There's been at least one study looking at that's demonstrated necrosis of the ruminal epithelium of cows fed seaweed. And also bromoform itself, which is various additives that involve just bromoform. It has a sort of a shelf life issue, and there's potentially a handling issue. We also need to think about scenarios. We've heavily focused on developed countries that have sort of contemporary production practices, but there's a severe need to look at developing countries as well. Grazing scenarios. There's a heavy emphasis on thinking about chemical sort of not just discovery, but registration, the regulatory approval process. There's a high call to think about how we expedite that. And we cannot forget about efficiency of production. And we think that in developing countries or countries with emerging economies, countries that are pretty, that are progressing, there's a high need here to enhance the efficiency of milk production, efficiency of meat production, simply because by doing so, we can reduce methane intensity. This is, from a scientific perspective, it's called the dilution of maintenance response, where maintenance requirements for specific animals doesn't change within an individual animal based on a per body weight basis. But if we can enhance milk per cow, average daily gain, we can reduce methane intensities. And in panel B, it's just showing milk yield that when it's real low, you can have very high methane intensities. And so there's a concerted effort, at least at Cornell, and I know at other institutions as well, to think about how we enhance the efficiency. At Cornell, we've partnered with the National Dairy Development Board of India, which I was happy to see the chairman presenting today. And we're working with the Environmental Defense Fund as well to build a feed database, enhance ration balancing so we can feed cows and buffalo to optimize their nutrition, health, and productive lifespan.